Hello everyone, my name is Nikhat and I'm going to explain the project MP3 Tag Reader and Editor. MP3 is an audio file. It will be having the audio details. With the help of MP3 Tag Reader and Editor, I'm going to view the details of a particular MP3 file and also I'm going to edit a particular file details. Whenever I have downloaded a particular MP3 file, I'm opening that particular MP3 file in some media player. It will play the song or audio and at the same time it will display some information. For example, it will display the name of a particular MP3 file, artist name and in which year the song or audio was composed, and will display the album image. If I want to view some properties of MP3 file, I will right click and open the properties of MP3 file. Once I open the properties, it will display some information like MP3 file name, and in which year the song was composed, and the size of the MP3 file will also be present. If I want to view some properties, I should right click and view. So here in this project we are creating a simple application. Like if I pass any MP3 file, I will be fetching some information from MP3 file and I will be displaying some information, and also I will be editing some information like if I want to edit the year in which year the song was composed, I can edit. Here I am performing two operations, like I am reading a MP3 file and also editing the same MP3 file. Then next we have is the introduction. MP3 Tag Reader. MP3 Tag Reader is a software which will read and display MP3 tag information from MP3 files. So MP3 Tag Reader is a software and it is a desktop based application. With the help of this software, I can read particular information about a MP3 file. Whichever MP3 file I am giving, it will display the information. About MP3 ID3 tag. ID3 is a metadata container. Metadata means whenever we have one or more information, so that we call it as metadata. So ID3 is a metadata container most often used in conjunction with the MP3 audio file format. It allows information such as title, artist, album, track number and other information about the file to be stored in the file itself. For MP3 we have a tag that is ID3. So this is the tag. Then next we have different versions of ID3. So there are two types of versions, that is ID3v1 and ID3v2. In ID3v1 we have two sub versions, that is ID3v1.0 and ID3v1.1. In ID3v1.0 we have audio data, ID3v1 tag, title, artist, album, year, comment and genre. Whereas in ID3v1.1 we have audio data, ID3v1 tag, title, artist, album, year, comment, genre and album track. In ID3v1.1 we can see we have more number of tags as compared to ID3v1.0. Here in ID3v1.1 we have an extra tag, that is album track. So whenever we want to have more number of tags, we can go with ID3v1.1. So the size of these tags are fixed. We will see here in the next slide. So the size for song title is 30 characters. The size for artist is 30 characters. The size for album is 30 characters. The size for year is 4 characters. The size for comment is 30 characters. The size for genre is 1 byte. So total 128 bytes is used for storing this metadata. So when we add this, that is 30 plus 30 plus 30 plus 4 plus 30 plus 1, we have 125 bytes together. But here we are saying that we have 128 bytes, so 3 bytes are remaining. So those missing 3 bytes can be found at very end of the tag before the song title. These 3 bytes are always tagged and is the identification that is indeed a ID3 tag. The next version is ID3v2 version. In ID3v2 version we have ID3v2.2, ID3v2.3, ID3v2.4. These are the versions under ID3v2. First we have ID3v2 header. In the ID3v2 header we have ID3v2 file identifier, ID3v2 version, ID3v2 flags, ID3v2 size. So all this together they will come under the header part, and for this 10 bytes of memory will be allocated. For ID3v2 file identifier we have ID3, so here 3 characters or 3 bytes of memory will be allocated for the file identifier. The next is ID3v2 version. in that we have 0300. This is the hexadecimal value. This value will be common for all the ID3 V2 version. That is, this will be common for ID3 V2.2, ID3 V2.3, ID3 V2.4. So this value will be common for all the ID3 V2 versions. The next, for this ID3 V2 version, 2 bytes of memory will be allocated. The next is ID3 V2 flags. For ID3 V2 flags, 1 byte of memory will be allocated. The next is for ID3 V2 size, 4 bytes of memory will be allocated. So here is the diagram. In this diagram we can see the first 2 rows will indicate the header of a particular MP3 file. So these 2 rows will indicate the header of a MP3 file. The next we have is the ID3 V2.2 frame header. So this frame ID is the tag name. The frame ID is of 3 characters. Under this frame ID we have TAL and TOA. So whenever we have the tag TAL, this will represent album, movie, show title, and whenever we have the tag TOA, this will represent original artist, performer. So for this frame ID, a total of 3 characters will be allocated, or 3 bytes of memory will be allocated. The next is size. Size is of 3 characters, so 3 bytes of memory will be allocated. Then next we have ID3 V2.2 or ID3 V2.4 frame header. So in that we have 4 frame ID. Again 4 bytes of memory will be allocated. So this frame ID is the tag name. So in that we have TALB. So whenever we see the tag TALB, in that tag we will be having album, movie, show title. And whenever we have the tag TI-T2, in that tag will be having title, song name, content and description. And the size is again 4 bytes. So 4 bytes of memory will be allocated. Flags. For flags, 2 bytes of memory will be allocated. The next is we have ID3 V2.3 frame header. So in that we have TPE1 tag. So in this TPE1 tag we will be having the artist name. The next tag is TI-T2. In this TI-T2 tag we will be having the title or song name. Then the next tag is TALB. In this tag we will be having the album. The next tag is TYER. In this tag we will be having the year. Then the next tag is TCON. In this tag we will be having the content type. So the next tag is TCOM. In this tag we will be having the composer. So this all represents the tag. So under this tag we will be having some details, like TPE1 will represent the artist name, TI-T2 will represent the song name, TALB will represent the album, TYER will represent the year, and TCON will represent the content type, and TCOM will represent the composer. These are the steps to perform the view operation. So to view, we are going to pass ./a.out followed by -v and the file name. So -v will represent that we are performing the view operation, and this is the file name. So we have to give the file name along with the .mp3 extension. So first we have to check for the command line argument. So to view the details of our mp3 file, we have to check whether we have passed the option -v. Then next we have to open the mp3 file. To open the file we have to use fopen. Here we are only viewing the file details. We are not performing any read or any write operation or any addition operation. So we have to open the file in the read mode. So we are going to use the option fopen. Then next we are going to check the ID3. After checking the ID3 tag, next we have to check the version, that is 0300, whether we have passed the correct hexadecimal value. Then next we have to check for the extension, that is .mp3, whether we have passed .mp3 extension or not. Next, if all the above conditions are true, then we have to call the function. This function is used to view the details of a particular file. For example, we have mp3 view.c. This is my file name, and suppose if I call the function, it will go to mp3 view.c. Inside the function definition, we have to write the code which is used to display the contents of a mp3 file. So in this mp3 file, all the functions will be present which is used to execute the view operation. The next is mp3 view.c. First we have to skip 10 bytes of header. To skip 10 bytes, we have to use the fseek function. After skipping 10 bytes, after skipping of 10 bytes of header, we will have tag, and we have to read the tag. Then only we can check whether the tag has TI-T2 or TP T1. Then next, after the tag we have to read the size. After reading the size we have to read the title. After reading the title, we have to display. You can use a temporary variable and store. Before storing we need to check whether we have read TIT2 or TPT1. To compare TIT2, we can use the strcmp function. If correct tag is read, we can copy read title in one variable. Copy read title in one variable. You need to repeat the above process for all other details like artist name, album name, year. You need to fetch like this. So for all you have to perform these operations. Next is edit operation. To perform the edit operation, I have to pass the option -e along with the file name. So whenever I pass /a.out-e, we are going to perform the edit operation. For example, if you want to edit the title, we have to pass the option -t. If I pass -t, we are going to edit the title. We need to pass the new title name along with the file name. You need to check for the command line argument whether we have passed the option -e, which means we are trying to modify the details of a MP3 file. After -e, we need to check which tag the user has passed, whether the user has passed -t or -a or -a or -y or -m or -c. -t is used to edit the title, -a is used to edit the artist name or album name, -y is used to edit the year, and -m is used to edit the content, and -c is used for the composer. Suppose if it is -t, which means we want to edit the title. So before this we need to open the MP3 file. So here we are going to read and write into the file. We should open the file in R+ mode, which will open the file in the read and write mode, and if you try to make some changes to that file, it will overwrite the old contents. We need to check whether it is ID3 or not. Next we need to check for the version, that is 0300, that is the hexadecimal value. Then after checking the version, we need to call for a particular function. If it is -t, here also we should not modify the header. The header is fixed. We need to skip the header part, which has 10 bytes of data. Next, after skipping the header, we need to read the tag. For example, if I have TIT2, next I need to read the size of a particular tag. After reading the size, we will have the contents of a particular tag. So here we are passing new title through the command line argument. So take a duplicate of a command line argument. If it is argument argv of 3, store this argv of 3 in some variable. This will be easy to replace the content. Next we need to check whether I have fetched TIT2. If it is TIT2, then write the duplicate variable content into the original file, that is the source file. So you need to repeat the process for all other options. Next we have main.c. In main.c you need to check for command line argument, whether command line argument has been passed or not. If it is not passed, you need to print the error and usage message. If we have passed -v, you need to call the function and perform the operation. Then you need to call a particular function, that is mp3 view.c. Next, if it is -e, you need to perform the operation. You need to check for the read, ID3 version, size. Once all the condition is true, you need to call the respective function, that is mp3 edit.c. In this mp3 edit.c file, I will be performing all the operation, like editing the title and all, and you can write all the edit function in this file. In editing we have 6 things, so we can write 6 different functions. So these are the files which I have created. I have created a main.c file, edit.c file, and view.c file. So this edit.h, types.h, and view.h are the header files, and the sample.mp3 file is an example file which I have used for this project. In this main.c file, I am going to check which argument the user has passed, whether the user has passed -e operation to perform the edit operation, or the user has passed -v option to perform the view operation. So this view.c file contains the function to perform the view operation, and this edit.c file contains the function to perform the edit operation. So first I have is main.c file. So in main.c file, first I'm going to check whether the arguments entered by the user are smaller than 2. So if the number of arguments entered by the user are smaller than 2, I'm going to print an error and usage message. So for example, if the user has entered only ./a.out, at that time I'm going to print an error message. So if the user has entered arguments greater than 2, then I'm going to check for the operation. I'm going to check operation of argv. So this function is present in this file. It is view.c. So I'm going to check the operation. So whether the user has passed -v or -e or -l help. So if the user has passed -v, I'm going to return p_view, which is used to perform the view operation. If the user has entered -e, I'm going to return p_edit, or if the user has entered -help, I'm going to return p_help. If none of the options are matched, I'm going to return p_unsupported. Then next, in the main.c, I'm going to check if the ret return value is equal to p_view, then I'm going to perform the view operation. Else, if the ret equal to p_edit, I'm going to perform the edit operation. Else, if the ret equal to p_help, I'm going to print the usage message, like in what format we have to specify the file names. And if ret equal to p_unsupported, I'm going to print error message. So this is about main.c file. The next is view.c file. So in the view.c file, we are going to first validate the command line argument. So whether the user has passed the argument. So here we are going to check whether the argument true is equal to null. So if it is equal to null, we are going to print an error message, like we have to pass .mp3 file name. So here the source mp3 file name shall be passed as a second command line argument as per the format. So if the file name is not passed correctly, then we are going to print an error message. So if the user has passed the correct file name, we are going to open the file in the read only mode. Then we are going to read the file signature. For our mp3 file, it is id3. So next we have to check if the file if the value read in str is matching with the mp3 file signature id. So if the file signature is not id3, it is not a .mp3 file and no further operation can be performed. If the file does not open, we cannot read and validate the arguments to the structure. So we are going to return p_failure. So if no p_failure is returned, then return p_success. So next we are going to perform the operation to view all the frame contents of the mp3 file tag. Then next we are going to view the contents of a particular frame ID. So this is about the view.c file. So next is the edit.c file. I'm going to open this edit.c file and I'm going to check the argument 2. So if the argument 2 is equal to null, I'm going to print an error message, or if the argument 2 is not equal to null, I'm going to check whether the option whichever option the user has passed, that is the user has passed -t or -a or -y or -g or -c. So based on the option entered by the user, I'm going to perform the operation, like -t. -t is used to edit the title, -a is used to edit the album, -a is used to edit the artist name, -y is used to edit the year, -c is used to edit the composer. So based on the options entered by the user, I'm going to edit that tag. So I'm going to show the execution of the project. So first I have to compile all the files. So I'll be using gcc star.c. So one a.out file will be generated. So if I run the a.out file without passing any arguments, so if I pass only a.out file, it is going to print me an error message. So it will print error, incorrect format of command line arguments. So if you want any help, you can give -help. So you can give a.out followed by -help. So it will print how we have to pass -a and -v option. So here we can pass -e followed by the file name and -v followed by the modifier, new value and the file name. So suppose if you want to edit a file, so if you want to, for example, first we will see how to view a file. So for example, if you want to view a file, you have to give a.out followed by -v and the file whichever you want to view, that is sample.mp3. so here you can see MP3 Tag Reader and editor, version ID, and title, artist, album, year, and content and comments. So if you want to edit any of the information, you can edit. So for example, if you want to edit the year, so here the year is 2024. So if you want to edit the year to 2020, you can give like this: a.out followed by -e and which tag you want to edit, that is -y, and the new value which you want to store in the file, that is 2020, and followed by the file name, that is sample.mp3. so the year will be edited. So we can see in the view option, by giving the view option, that is -v. So we can see here the year has been edited to 2020. So here we can see earlier the year was 2024, now the year has been edited to 2020. So this is how we are going to view and edit the file. So this was all about the MP3 Tag Reader and editor. Thank you.